SJBIT. Today in this session we are going to learn about module 2 session 8, which is on Magic T, module 2, which is about microwave network theory and passive devices. Under the passive devices, in the previous session we have learned about waveguide T's, E plane and H plane T. Here you are going to learn about Magic T, and which is a combination of E and H, and the S matrix derivation of Magic T, followed by the applications of Magic T. You look at Magic T, or we also call it as a hybrid T. It is formed by combining the E and H plane T's. So that's the reason why I call it as a Magic T. The Magic T, which has the following characteristics, with all the ports are terminated with the magic loads. All ports are terminated with the magic loads. It's an important one, indicating that the diagonal components of the S matrix will become 0. All ports are terminated with a perfectly matched one. And first one, if you observe, if the two waves are given equal amplitude and equal phase, which we have fed into port 1 and port 2. Port 1, port 2, we call it as a collinear ports. And the output at port 3, if you observe, it is a subtractive difference between the inputs which you have applied at port 1 and 2. And the total output which will appear additively at port 4. So port 4 we call it as a sum arm, and port 3 we call it as a difference arm. So difference arm we also call it as a E arm, and sum arm we also call it as a H arm. Okay. Then and if a wave is incident at port 3 I had given an input, let us consider. So that will get divided equally into port 1 and 2, but with opposite in phase. And there is no coupling to port 4, that is head to H arm, we don't have any coupling. So which will be represented in S parameters as I had given input at port 3. You can observe here port 3. Sij, in Sij, ith port is the output port and jth port is the input. So you can observe I had given input at port 3, observing at port 1 and 2, I am getting equal but opposite in phase. So S13 is minus S23, and S43 is 0 because no coupling to port 4. So S43 has become 0. In the same manner, suppose I had given an input at port 4. So that will get equally divided between ports 1 and 2 at in phase, and there is no coupling to port 3. So in the similar manner, you can write or you can express this as S14 is equal to S14 is equal to 41 because of the symmetry. S114 is equal to S24. So I am observing input is given at port 4, output is taken at port 1 and 2. So you can observe you will have an equal amount of power divided into port 1 and 2, but there is no coupling at port 3. So S34 will be 0. So S43 and S34 are zeros. S13 is equal to minus S23. S14 equal to S24, so which is same as S42 and S41. And let us consider one more characteristic, like suppose if a wave is fed into one of the collinear port, like either port 1 or port 2, and it will not appear in any other collinear port. So we say that it is isolated. Similarly, if I gave input at port 2 and none of the power is appeared at port 1. So we say that the collinear ports 1 and 2 are also isolated from each other. So which gives you S12 equals to S21, which is equal to 0, indicating from these four properties you have a E arm and H arm, you call it as a difference arm and sum arm. And if I gave input at port 3, equal division but with 180-degree phase shift, you can observe at port 1 and 2. If I gave input at port 4, equal division occurs at port 1 and 2, no power output at port 4, port 3. And if I gave input at one port, other port we don't have output, that is even collinear ports are also isolated from each other. Then using these three, this is a diagram of Magic T. You can observe here. This is a collinear arm, port 1, collinear arm, port 2, and E arm, we call it as a series arm or a difference arm. or you can say that the axis which is parallel to electric field, and we call this as a port 4, which is a sum arm or also called as a H arm. The axis which is parallel to magnetic field, and this is the one considering magic magic T with the port 3 and 4. If you interchange, you can express this in terms of port 3 you can consider as a H arm, or port 4 considered as a difference arm. E arm and shunt connection and series connection you need to observe. 3 and 4 numbering you can change. If you change the numbering, accordingly S parameters will change. Okay, so here numbering is changed, but not the geometry wise. Geometry wise same. Geometry is retained. Okay, so E arm which is connected in shunt, whereas some arm which is E arm connected in series, H arm connected in shunt. Now we need to determine the S matrix of magic T. So as it is a 4 cross 4 matrix, since it is a 4 port device, port 1 and 2 are collinear ports, 3 and 4 are E arm and H arm. So we have 4 cross 4 S matrix. To determine all these S matrix, S values, parameters, we apply the properties. So with respect to the symmetry property, you can observe S41 equals to S14, which is equal to S24. Reason, this is with respect to H arm. If I give input at port 4, equal amount of power division occurs at 1 and 2. So S14 equals to S42, and which is equal to S42. Similarly, S13 equals to S31, which is equal to minus S23. This is with respect to the difference arm, that is E arm. And S34, S34, S43 equals to 0. And S12, S21 equals to 0. This is with respect to all the ports are matched ports. So you can say that, and S33, S44 are zeros, indicating that it is perfectly matched. That is port 3 and 4 are perfectly matched. So you can write into the equation, into the S matrix, by substituting all these values. You can find out first 4 values same, S12 same as S21 due to symmetry, and S23 which is same as S13 minus S13. Then this is S24 which is same as S14. So similarly the third column S31 same as S13, S23 minus S13, and the last 4 values will become 0, because these 3 indicating S33, S44. They are perfectly matched, and these two indicating it is S34 and S43. Uh, Suppose if I give input at port 3, nothing will be seen at port 4. If I give input at port 4, nothing will be seen at port 3. So indicating that last 4 values will become 0. Now you apply unitary property for this to determine the unknown values. So 16 unknown values has been reduced to by applying these properties. So which has been reduced to 5 values. These 5 values you can determine by applying unitary property to the S matrix. So first row 1 and row 2, if I apply unitary property, which gives you S11 square plus S12 square plus S13 square plus S14 square equals to 1. Even in the same case with second row, then by subtracting these two rows, you can observe S12 you have in equation 1, even 2 you have, and S13 you have, S14 also you have. So we will be left out with S11, S12. If I subtract those two, S11 square minus S11, S22 square, you will get to 0. So which gives you S11 same as S22. So we got S11 same as S22 again. And in the same manner, the other properties can be determined by applying for row 4 and row 5, row 3 and row 4. You column row 3 and row 4. If I write S13 square plus S13 square, that is unitary property, if I apply equals to 1, so which gives you 2 into S13 square equals to 1, so which gives you S13 square as 1 by root, S13 as 1 by root 2. Similarly, S14 as 1 by root 2. Got to know S3 and S14. So 2 into S13 square equals to 1, and S13 as 1 by root 2, S14 as 1 by root 2. So we got S13, S14 values. substitute these values into any one of the equation. So previous equation, if I substitute S11 square plus S12 square plus half S13 square plus S14 square, so which gives you equals to 1. From this, S11 square, half plus half 1, other side also you have 1, so by subtracting those two will become 0. Left out with S11 square plus S12 square equals to 0. And this is valid if S11 equals to S12. One value cannot become 0 because S11 must be equals to S12. If this equation has to be satisfied, then both the terms must become 0 or must become equal. So S11 value we got to know, S13 we got to know, S14 we got to know, and even S12 we got to know, S21 also we got to know. So substitute all these things into the above equation. You will get the first 4 diagonal values and last 4 diagonal values has become 0, and these values are left out with S13 and S13, S13, S1 minus S13 minus S13. Already we know S13 values, which is 1 by root 2. You can substitute, and you can say that port 1, 2, 3, 4, all diagonal components. You observe the diagonal components S11, S22, S33, S44. All the diagonal components has become 0, indicating that the magic T is perfectly, all the ports in magic T are perfectly matched. Whereas in E plane T and H plane T, we assume port 3 is perfectly matched. Not port 1 and 2. Port 3 is perfectly matched considering S33 as 0. Any one port. Whereas in magic T, all 4 ports are perfectly matched. This is a final S matrix of magic T, which you can observe by taking 1 by root 2 common. You can express with port 3 and 4 as E and H. In the similar manner, if I interchange the ports, so you can observe the variation in S matrix. And in the same manner as we had seen in case of E plane and H plane T, here also you can write the 4 equations relating B equals to S into A. 4 equations like B1, B2, B3, B4. B1 you will get it as considering 3 and 4 first S matrix. You will get B1 equals to 1 by root 2 A3 plus 1 by root 2 A4. Similarly, B2 equals to minus 1 by root 2 A3 plus 1 by root 2 A4. B3 you will get as 1 by root 2 A1 plus minus 1 by root 2 A2. And B4 you will get as 1 by root 2 A1 plus 1 by root 2 A2. Likewise, different cases that you can consider. Input is given at port 3. How about B1, B2, B3, B4 values? From that you can conclude whether the power has been coupled into port 1. If I give at port 3, one case I will see. Suppose I had given input at port 3. You can observe B1, B2, B3 equation. Nothing I had given with other ports. Okay, so that is A1, A2, A3 has become A1, A2 and A4 has become 0. A3 is not 0. Then in that case, if I write B1 value, you'll get as 1 by root 2, and B2 value will get as minus 1 by root 2, whereas B3 and B4 will become 0 because A1, A2 0, no? So you'll be left out with if I give input at port 3, if I give input at port 3, then you will get equal amount of power at port 1 and 2, but with 180 degree half 180 degree phase shift. In the same manner, you can observe for the other ports. Other analysis can be interpreted. If you look at the applications of Magic T, the Magic T, you have various applications in microwave circuits as EH tuner for impedance matching, balanced mixer in a microwave super heterodyne receiver, and you can make use this as a power combiner and duplexer. So coming to EH tuner, each and every application we'll see. EH tuner, you can observe 4 ports you have. You can observe here in the diagram a variable short has been connected in the H arm as well as in the E arm. So by connecting variable or movable shorts in E arm and H arm, you can adjust the impedance. The wide range of load impedances can be matched to reduce the VSWR value, which is connected to through collinear arms. So for impedance matching purpose, you will be connecting a variable short. By adjusting that, you can adjust the impedance. So impedance matching can be attained, and hence VSWR reflections can be reduced. And the other one, you observe it can be used as a balanced mixer in super heterodyne receiver. If you recollect the super heterodyne receiver, you have a RF radio frequency signal from RF amplifier, and local oscillator signal you have from local oscillator. These two signals which will be combined in the mixer, and the output you will get as a IF, intermediate frequency. At the output of a mixer you will have some frequency, difference frequency, and number of components you have. Among that, difference frequency will be tuned by the IF amplifier. So the same configuration which you can attain in the microwave region by using Magic T. So one of the signal, that means radio frequency signal, which has been given to port 1, and here you can observe for port 2 which has been connected with a choke and diode, and port 4 uh, we had given with a local oscillator, and the signal which has been given at port 3, you can observe the output at port 2. So balanced mixer is a balanced microwave mixer configuration. An incoming signal which is fed to E arm, and the local oscillator signal which is fed to H arm. When these two signals enters into the collinear arm, the cluster detectors which you have placed at these two arms, they will produce the IF signal or different signal. So signal, actual incoming signal given to E arm, and local oscillator signal which has been given to H arm. So these two signal, by connecting a difference, means if I give input at E arm, what will happen? The difference will equal amount of power which has been generated at port 1 and 2, but with 180-degree phase shift. If I give at local oscillator input, equal amount of power will be generated, but with no phase shift. So at one of the, means you have connected a diode which will be detecting the IF signal here. Okay. You can observe the same thing which has been explained. The local oscillator signal, which is from the H arm, will arrive at the diodes in the collinear arms, which will be in phase, no phase shift. Whereas the incoming signal from the E arm will arrive at the diodes with out of phase. So these two signals which are mixed in the nonlinear diodes, and which will produce the intermediate frequency signal in the collinear arm, and these two are which are out of phase by 180 degrees. Since the local oscillator noise will be in phase at the diode, that will get cancelled at the balanced IF input to the IF amplifier, whereas IF signals are added up in phase for the amplification. Any noise signal which will get cancelled, and any IF signal if you have which will get added up in phase. So local oscillator and RF signals which are uncoupled due to magic T, because they have property of according to the property of magic T, E and H planes are isolated. So obviously these two signals are uncoupled. In a duplexer of a radar system, that is the last application, duplexer which is used in radar system. So usually a common antenna which is connected to port 1, while the transmitter and the receiver which are connected to isolated E and H arms, and a dummy load which has been connected at port 2. So you can observe half of the power transmitted to the coupled antenna, half of the power transmitted which is coupled to the antenna, and 50% of the received power gets into the receiver, and the remaining 50% of the power which is absorbed by the dummy load. So that you can identify yeah, add power output at the dummy load. Okay. So this is about the Magic T, applications of Magic T, which is used as a EH tuner for impedance matching, and is used in balanced as a balanced mixer in the case of super heterodyne receiver at microwave signals, and it can also be used as a duplexer in radar system. Okay, thank you.